Now we will discuss most awaited topic in communication is random variable. It's very simple topic but very important topic. Random variable. We discuss step by step all the points regarding random variable. Random variable, it specifies the process of assigning value to the outcome of an experiment. It is a process assigning value to the outcome of experiment. Outcome means flip a coin. It's an experiment. Outcome may be head or tail. Assigning value. I assign a value to head is half, to tail is half. This process is known as random variable. Random variable, random and deterministic. Two type of pattern is there. Deterministic and random. A signal, a receiver, Rx, some input is there. Input SNR, signal to noise ratio, and output SNR. SNR, our portion denominator of this is deterministic signal and numerator is random in nature. Random in nature, non-deterministic signal. Deterministic signal means a cos omega ct. We can determine any type, any time value of this waveform. We can calculate value at 10 second, 100 second, 200 second, anytime. Any parameter. Second definition of random variable, any parameter which change randomly with time or space is called random variable. Random variable is denoted by capital X and its value is denoted by smalls. If capital X, capital Y and capital Z are random variable, its value can be denoted by x1, x2, small x1, x2, x3, y1, y2 and z1, z2 and so on. Two type of random variable is there, continuous random variable CRV and second is DRV, discrete random variable. Continuous random variable means it take on infinite number of value as continuous random variable. Infinite number of value, finite number of value, finite number of value is discrete random variable. Continuous random variable and discrete random variable. We can further differentiate these two random variable. For an example, in an office, a receptionist attend a call in throughout a day from 10 to 5 standard office time. She receive call from 10 to 5 uh, and collect all the datas. Next day, boss come and retrieve all the data in two way. In first way, he call them and ask data arrange in this way from 10 to 11, call between 10 to 11, call between 10 to 11, 11 to 12, 12 to 13 and so on, 14 to 15, 10 to 5. It might be 7, 10, 6, 4 and so on, and in different values. Second idea, call at 10 o'clock 15 minute 52 second, all the different time value and call detail. This pattern is known as DRV. This collection pattern is known as DRV, discrete random variable. In each time slot, data is random in nature, so discrete random variable. In the time slot of 10 to 5 p.m. am, all the data is merged up. All the data is unique. 11 o'clock 52 minutes 17 seconds. At that time, one call occur. Detail of call is 7 minutes, 2 minutes, 3 minutes, XYZ. This type of presentation is known as CRV, continuous random variable. DRV and CRV. Value assignment is known as random variable of outcome of an event. I assume a domain have multiple outcome lambda 1, lambda 2, lambda 3. I assigned this a value on real axis known as random variable x. I assign value x lambda 1 to lambda 1, lambda 2 to x lambda 2, lambda 3 to 1 to 1 mapping means one event assigned one value. It might be all the sample value assign same value. From this range I lambda I assign a value to lambda 3, lambda 2 and lambda 1. This is possible. We can assign similar value to all the sample, but this is not possible. Lambda 1, lambda 2 and lambda 3 we assign some value x lambda and again assign one more value x lambda x1 or x2, again assign two value. So two different value on the real line can't be assigned to an sample. Then move ahead with some formulas. Probability of x small x equals to lambda x lambda x less than equals to lambda x lambda less than x. X1 x2 I assign value point of value directly assign a probability range assign the range within the range same pattern assigned into the probability. Now take an example this thing more further clear. I take an urn contain 4 white ball and 3 black balls. Two balls are drawn successively continuously with x denoting a random variable number of black balls. Find the probability of x and draw PDF probability density function. First, sample space S is denoted by, and what is the definition of random variable is capital X is number of black balls, sorry. Samples are two iteration. It might be both are white, both are black, one white, one black, black and white, last case. All four possible value exist there. Number of balls is x. X now represent what are the value of x? 0 maybe, 1 maybe, 2 maybe. 0 black ball, 1 black ball, 2 black ball. These are the possibility between for this operation event. For the probability purpose, probability of zero outcome is probability of zero outcome is out of 4 white ball 7, out of 7 4 white ball, any white ball can become 3 6, result will be 2 by 7. Next move ahead x1, where one white ball come out in this way, first white maybe second white. If first white 4 by 7, second one is black 3 by 6 plus first black 3 by 6, first white 4 by 7. Solve this, get 2. Both are white, sorry, both are black. Both black case 3 by 7, 2 by 6. Result is 1 by 7. We have three answer. We can arrange in these answer in this way. X is 0, 1, 2, 2 by 7, 4 by 7, 1 by 7. Probabilities are. We can draw in PDF diagram probability density function diagram 0, 1 and 2. At 0 case 2 by 7, 1 case 4 by 7 and 2 case 1 by 7. Complete probability is 1. PDF of this. Let's take a second example. In random experiment, a trial consists of 4 successive toss, 4 trial, 4 toss, 4 successive tosses of a coin. Definition of x is, define a random variable x. Definition of x is number of heads appear in a trial. Solution for this is 4 trial means 4 successive toss means total number of sample is 2 power 16. 2 power 16. X define number of heads appear. In 4 trial, head may be 0, 1, 2, 3 and 4, all 4. These 5 possible case: 0 head, 1 head, 2 head, 3 head, 4 head. One idea, write down the all 16 possible case and search out for 0 head, 1 head case, 2 head case, 3 head case, 4 head cases. All the cases we can search out. For searching out all the cases, we map a Bernoulli diagram. For 1 trial, 0 trial, 2 trial, 3 trial, 4 trial and 5th trial and so on. 4 trial means 0 head case, 1 head case, 2 head case, 3 head case, 4 head case. We can directly write probability for that. x00 is 1 by 16, x01 equals to 4 by 16, x2 equals to 6 by 16, 3 equals to 4 by 16, 1 by 16. All the possible cases are available to us and we can draw also. Now we will discuss second term. First, PDF probability density function. This is marked in small letter. Capital letter PDF. Probability distribution function, which is also known as CDF. Both are similar. Cumulative distribution function. It is defined in this way: probability x less than x. Fx means CDF of random variable x. CDF of random variable x is the probability that x takes a value less than equal to x. That is, property for CDF is always greater than 0, always positive value. At infinite it is 0, because from where it is start. Minus infinite, sorry. At infinite it is 1. At minus infinite it is start. At infinite it terminate. Maximum value of this. And fx is non-decreasing function that shows x1 fx x2 for x1 less than this. If x2 is greater than x1, then CDF is also greater. We can understand this through an example. Example: rolling a dice. Some randomness is given to us. 10i equals to 1 2 3 4 5 6. Sample space: rolling a dice have 6 sample space: 1 2 3 4 5 6. All the sample space converted into I equals to 1 2 3 4 5 6. X of xi equals to 10 20 30 40 50 or 60. Value attached with, because all are equiprobable unbiased dice, means all are assigned 1 by 6 probability. Assigned value is 1 by 6. We can calculate some CDF value for that via either diagram, or first we try without diagram. If we made diagram for that, it is very easy to calculate by viewing. 30. How can we calculate? 30 come from P 10 P 20 P of 30. Accumulate all these value, result will be 1 by 2. In this way we calculate 30. If we want to calculate probability x included 30, so first we draw CDF diagram. 1 by 6, 20, 10, 30, 40, 50 or 60. If we want to calculate fx 30, means we are calculating value of this point, means directly half, or add these three value. If we want to calculate probability x 30, means all three sample value 10 20 and 30 all are included, means it is also half. If we want to calculate 20 to 30, means in between value 20 to 30, in between value no value exists, so it is 0. Last 10 included and 30 not included, means these two value. 1 by 3. We can move ahead. PDF of this and CDF. PDF of random variable is impulse and CDF is step. Means CDF and PDF relation between CDF and PDF is integration relation. Integration relation. Impulse, it is step. It is step, it is ramp. Impulse signal. Step. Converted into step. A question is given in 2005 GATE question paper. Is CDF is given to us and x is random variable denoted, and we want to calculate probability x equals to 1 at location 1. CDF for this location is 0.55 and previous value is 0.25. So probability at this point, a particular point, is, because CDF, what is CDF? CDF is just accumulation of previous value. Probability x, capital X, less than, at a particular point we get, if we want to calculate the particular point probability, means we have to subtract current value minus previous all value, means probability of x equals to x minus probability of x less than x. In both cases it is correct. So we subtract these value, result will be 0.55, 0.25, result is 0.3. So our answer is 0.3. Now we will discuss about continuous random variable. Continuous RV. Continuous random variable takes infinite number of values, as we know. In continuous random variable, probability lies between two different point is non-zero. For continuous random variable PDF, some property we are writing here is always greater than 0, and for continuous or discrete, probability area under the PDF curve is always 1. Very important property, if we want to calculate probability between A and B, two different point, which can be calculated area between PDF between these 2 points through PDF graph. In this case, all the probability criteria are equal. I am writing all the cases for the continuous case. Probability of x being equals to particular value is 0. For continuous case, at a particular value is 0 for continuous random variable. So we can use in this way, all are equal, means less than or less than equals to is equal in this regard. Now we write a relation between PDF and CDF is this type of relation. Now I draw both type of PDF and CDF for continuous case both type of pattern fx area under 2 points x1 x2 I mark here in this way. Area is from x1 to x2 fx dx. Probability b. For CDF I draw this diagram. This is non-decreasing graph 1. I mark these 2 points x1 and x2 again. This area is shown here. Now PDF area is now converted into CDF in this way. Fx x1 x2 minus fx x1. This point x2, this is x1. Difference between these 2 points is diagonally probability. And area covered by this graph, PDF graph, is always 1. And for CDF infinite it is 1, and for minus infinite it is minus 1. Sorry, 0. I discussed last two formulas for probability calculation from CDF graph or PDF graph is greater than particular value x1 to infinite fx dx. These two are important formula. Now we discussed some standard pattern of density function. Uniform density function. This is very important. From last 2 years in GATE, at least one question from uniform density function. UDF, uniform density function. I draw a UDF from A to B. Height of this UDF is B minus A, 1 upon B minus A. If it is continuous, CRV. If it is discrete, DRV, then UDF is n point 1 upon n is the height of this. If PDF is constant within a specified range, the random variable is said to be uniformly distributed.